Welcome friends to the session. In this session, we'll be discussing about the number systems. You will find that in the study of digital electronics, the number systems are frequently required. And therefore, whenever we start the study of digital electronics, we always start it with the study of number systems. In this session, we will discuss what are number systems, what are the different types of number systems, and how the numbers can be represented in these number systems. Also, we will see what are the uses of these different number systems. As you know that you are viewing this session on my YouTube channel, Learn with Prakash Khanale, and don't forget to subscribe to the channel. In our daily lives, you will find that we are always dealing with the numbers. Say we have mobile phones or landline phones, and your mobile phone is being recognized by the mobile number. The rooms in the hotel have room numbers. A book has several pages, and every page is being identified by a page number. Our bus has a number, our train has a number, our flight also has a specific number. Our currency is being calculated or measured by using numbers only. Whenever we play some games, then the cards are also recognized by the numbers. Your date is a number, your time is also a number. So you will find that in our everyday life, we are dealing with a large set of numbers. Every now and then, we need to quantify the things in the form of the numbers. Whenever we measure anything, then that measurement is done with numbers only. The market falls, or when the market gains, it is also measured in the form of numbers. The economy of the country is also measured in the form of numbers. So from where these numbers comes in, you will find that these numbers are there with the help of the number systems. So basically, you will find that a number system is a collection of symbols, and this individual symbol is being called as a number. And it is not only collection of symbols, but it is also collection of various rules, and these rules will tell us how to perform different operations on these numbers. You will find that every symbol is a specific number, and these numbers can be positive numbers, negative numbers, they can be whole numbers, and as well as they can be fractional numbers. In any number system, we can write as many numbers as we want. So there is no restriction. You can write infinite numbers by using any number system. We can perform various arithmetic operations such as addition, subtraction, multiplication, and division on these numbers. So every number system has some set of rules, and by using this set of rules, we can perform any arithmetic operation on these numbers. You will find that every number system has some set of fixed basic numbers, and this basic numbers is being called as the base of the number system. So every number system has a typical base, and every number system will have its own base. You will find that the value of any number in a number system will depend upon what kind of digits you are using in the number. It also depend upon what is the position of this digit and what is the base of the number system. You will find that there are four most commonly used number systems. The first number system is the decimal number system, which is being practiced by us in our daily lives. Another number system is a binary number system. This number system is used in digital electronics or in the study of computers. Octal number system and hexadecimal number systems can be used when we write the programs either by using high level language or by using assembly level language programs. So in this session, we are going to discuss all such four number systems, and we will see how the numbers can be written by using these number systems. So let us start with the first number system, and that is the decimal number system. Now, as its name indicates, deci, it will stand for 10. That is, this is the number system which has a base of 10. That is, there are 10 basic symbols or 10 basic numbers, and these numbers are from 0 to 9. So whenever I want to write the numbers in the decimal number system, then I can start with 0, then 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now the basic numbers are over, and therefore I need to make combination of 1 and 0. So the next number is 10, 1, 0, 11, 12, 13. And in that way, you will find that I can write infinite numbers by using this number system. Decimal numbers can be positive numbers, they can be negative numbers, they can be whole numbers, as well as they can be fractional numbers. Say for example, when we do not write any sign before the number, or when we write the plus sign before the number, then that number is being treated as a positive decimal number. And whenever we want to write any negative decimal number, then we need to write a negation symbol or minus sign to indicate that this is a negative number. Whenever we are writing any fractional number in the decimal number system, then you need to make use of the decimal point. Say for example, here I have written a number 12.67. So this is a decimal point, and this part of the number is being called as an integer part, and this part of the number is being called as a fractional part. You will find that whenever there are different digits in the decimal number, then every individual digit will have certain weight, and this weight will be in the powers of 10. So when we start from the decimal point and when we go to the left hand side, the weight will go on increasing in the powers of 10. So the first two will have a weight 10 to the power 0, and this one will have a weight 10 to the power 1. And for the fractional part, when we go to the right hand side, the weight will go on decreasing, and this 6 will have a weight 10 to the power minus 1, and this 7 will have a weight 10 to the power minus 2. Now these are the different examples of how numbers can be written in decimal number system. Suppose this is my first number 25.386, and now to indicate that this is a decimal number, what I do is that I write 10 at the suffix. So it indicates that this is a decimal number. Similarly, this is a negative fractional decimal number, this is a whole number, and this is a fractional decimal number with positive sign. Another number system that is being commonly used in computers or in the study of digital electronics, and this number system is being called as a binary number system. So this word bi, it will stand for 2. So this is a number system which has a base of 2 only. That is, there are only 2 basic symbols, and these basic symbols are 0 and 1. Therefore, whenever I want to write the numbers in the binary number system, then they can be written like this. The first number is 0, second number is 1, then the basic numbers are over, and therefore the third number can be written as 10. That is by making the combination of 1 and 0. Then 11, then 100, then 101. And in this way, you can write infinite numbers in the binary number system. Like the decimal number system, in binary number system also, numbers can be positive, negative, whole numbers, and fractional numbers. Whenever we do not write any sign or plus sign before the number, then that is being treated as a positive binary number. In case of negative binary number, you will find that there are different ways of writing the negative binary number. Say for example, you can write a minus sign, or you can use the first bit of the number as a sign bit, or you can use the ones complement form, or you can use the twos complement form of writing the negative number. So there are 4 different ways for writing the negative binary number. Maybe in the next session, we will discuss about this ones and twos complement method of writing the binary numbers. You will find that whenever we write any fractional number, then the fractional number has to be written with a binary point. Say for example, this is my binary number 10.00. 0.01. Now this is the binary point, and you will find that this part is the integer part and the right hand part is being called as a fractional part. Now whenever we write any binary bit, then every binary bit in the binary number will have a weight, and this weight is in the powers of 2. In case of decimal, the weight is in the powers of 10. In case of binary, the weight is in the powers of 2. So the first 0 will have a weight 2 to the power 0. The second one will have a weight 2 to the power 1. If you go to the right hand side, then the weight will go on decreasing. The first 0 will have a weight 2 to the power minus 1, and the second one will have a weight 2 to the power minus 2. So these are the different examples of binary numbers. The first number that we have written is 11011.1, and now to indicate that this is a binary number, what I do is that I write a suffix 2 indicating that this is a binary number. The second one is a negative binary number, and the third one is a positive fractional binary number. Another number system that is being commonly used is the octal number system. Now, as its name suggests, this number system has a base of 8. That is, there are 8 basic symbols or 8 basic numbers, and these numbers are from 0 to 7. So whenever I want to write any octal number, then it can be written like this: 0, 1, 2, 3, 4, 5, 6, and 7. So these are the basic numbers. Therefore, after 7, in octal number system, we make the combination of 1 and 0 to write the number 10, then 11, then 12. And like that, you can write infinite numbers in octal number system. In octal number system also, numbers can be positive, negative, whole numbers, and fractional numbers. Whenever we do not have any sign before the number, then that number is being treated as a positive octal number. If we write any sign such as negation symbol, then that number is being treated as a negative octal number. Whenever we write a fractional octal number, then that is to be written by using the octal point. Say for example, this is my octal number 12.67. Now this is the octal point, and before the octal point, the part of the number is being called as an integer part, and after the octal point, the part of the number is being called as a fractional part. Now whenever we write any octal number, then it contains octal digits, and every octal digit will have a weight, and this weight is in the powers of 8. Therefore this 2 will have a weight 8 to the power 0, and this one will have a weight 8 to the power 1. That is, the weight will go on increasing to the left hand side. And when we go to the right hand side, then you will find that this 6 will have a weight 8 to the power minus 1, and this 7 will have a weight 8 to the power minus 2. That is, the weight will go on decreasing to the right hand side. The biggest advantage with the octal number system is that any octal number can be easily converted into binary, or any binary number can be easily converted into octal. And therefore, whenever we are dealing with large binary numbers, then it is always better to write these binary numbers in octal form. So for example, we have a octal number 234.54. Now to indicate that this is an octal number, here at the suffix we write 8. Similarly, this is a negative octal number, and this is a fractional positive octal number. Another number system that is being frequently required in the study of electronics is the hexadecimal number system. Now, as its name suggests, hexadecimal number system has a base of 16. That is, there are 16 basic symbols. Now, we know that the numbers are from 0 to 9. The basic numbers are from 0 to 9. And now we require more symbols, and therefore the letters A to F are used as the basic symbols of the hexadecimal number system. In hexadecimal number system, we can write the numbers like this: so 0, 1, 2, 3, 4, up to 9. After 9, we write the basic numbers as A, B, C, D, E, and F. Now the basic numbers are over, and therefore after F, we make the combination of 1 and 0. Therefore 10, 11, 12, 13. In this way, you will find that we can write the infinite numbers in the hexadecimal number system. In hexadecimal number system also, numbers can be positive, negative, whole numbers, and fractional numbers. Whenever we do not write any sign or plus sign, then that number is being treated as a positive number. Whenever we write a negative sign, then that number is being treated as a negative number. If you want to write any fractional number in the hexadecimal number system, then you need to make use of the point, and this point is being called as a hexadecimal point. Say for example, this is a number I have written 1a.6. So this is my hexadecimal point. This part is integer part and this part is the fractional part. Now, whenever we write any hexadecimal number, then it contains some hexadecimal digits, and every hexadecimal digit will have a weight, and this weight is in the powers of 16. Say for example, this A has a weight of 16 raised to 0, and this 1 has a weight of 16 raised to 1. This 6 has a weight of 16 raised to minus 1. And if there would have been any other digit, then the weight will be 16 raised to minus 2. So you will find that the weight to the right hand side will go on decreasing, and the weight to the left hand side will go on increasing from the hexadecimal point. You will find that like octal number, there is some advantage of hexadecimal number system, and the advantage is that any hexadecimal number can be easily converted into binary form, or any binary number can be easily converted into hexadecimal form. Therefore, whenever we are dealing with big set of binary numbers, then it is always better to write it either in the octal form or in the hexadecimal form. Say for example, this is a number 1a.bc. Now in order to indicate that this is an hexadecimal number, I write at the base 16, isn't it? So at the suffix, the number 16 is being written to indicate that this is a hexadecimal number. Similarly, here we have written a negative hexadecimal number, and this is another positive fractional hexadecimal number. Now, this is a table which will show us how the numbers can be written in different number systems. So for example, 0 is same in all number systems. Similarly, 1 is same in all number systems. But when we write 2 in the decimal number system, in binary there is no 2, and therefore we need to make the combination of 1 and 0. Therefore, the 2 in the decimal is written as 10 in binary. But in octal and in hexadecimal, 2 is there, therefore it is written as it is. 3 is being written as 11 in binary, and it is written as 3 only in octal and hexadecimal. 4 decimal is being written as 100 in binary, and 4 number is already there in octal and hexadecimal. So you will find that in any number system, whenever we write the next number, then we need to add 1 to the previous number. Say for example, when we add 1 to the 4, then we get 5. And when we add 1 to 100, then we get 101. And 5 is being written same as octal and hexadecimal number. For 6, we write 110 in binary. 6 is written as it is in octal and hexadecimal. For 7, we write 111 in binary. 7 is written as it is in octal and hexadecimal. For 8, we write 1000 in binary. But now the octal numbers are over, means the basic numbers are over, and therefore we write 10 for the decimal 8. And in hexadecimal, 8 is being written as it is. For 9, we write 1001 in binary, 11 in octal, and 9 is being written as it is in hexadecimal. When we write 10 in decimal, then in binary it is being written as 1010, and in octal it is written as 12. Now the basic numbers of hexadecimal are over, and therefore we use the letter A for writing 10 in decimal. Now 11 is being written as 1011, 13 in octal, and as B in the hexadecimal. In this way, you will find that when we write the 15 number in the decimal number system, then this 15 is being written as 1111 in binary. It is being written as 17 in octal, and it is being written as F in hexadecimal number system. Now the basic numbers of hexadecimal are over, and therefore whenever we write the 16 decimal number, then this 16 decimal number is being written as 1000 in binary, 20 as octal, and in hexadecimal this number is being written as 10. Now let us see how these number systems are used in real life. You will find that the decimal number system has a base 10 and it has 10 basic symbols from 0 to 9. This number system is used by the humans in our day-to-day life. Binary number system has a base of 2. It has only two basic symbols, 0 and 1. This number system is not used by the humans, but it is used only in computers and in the study of digital electronics. So whenever the data is internally stored in computer memory, then it is always stored in the form of 0 and 1. Octal number system has a base of 8 and there are 8 basic symbols from 0 to 7. This number system is not used by the humans, but this number system can be used while writing the programs in either high level language or in low level language. Hexadecimal number system has a base of 16. It has the basic symbols from 0 to 9 and A to F. This number system is not used by the humans, but we need to make use of these number systems while writing assembly language programs. So while writing assembly language programs, this number system is very useful. So thank you friends for viewing this session. Hopefully you have understood what we mean by the number systems. So thank you all for viewing the session.